All right, students, obviously I'm not here today, but wanted to go through, this is learning target 3F. We'll come back to 3E after fall break, but this is just a very quick one. And really all we're going to be doing here as I scroll down on page 18 in the notes packet, we're just going to be using this b squared minus 4ac. Now, you might remember this formula from something in previous years, and we're going to go back and talk about this. But here's in short how we're still tying this together. When we're doing this, you know that the x-intercepts, we can find them using factoring, right? We could find them using completing the square. There is another way to do that, which we'll talk about after fall break. But in short, what if we just want to know how many times the graph touches the x-axis, right? And that's something. And we're going to use this formula, b squared minus 4ac, to help us out with that. All right, so here's what it is. This b squared minus 4ac is what we call the discriminant. And we're going to use just these the small formula to help us out. So finding the discriminant of the quadratic equation tells how many x-intercepts it has. Remember, different words we could use are roots, zeros, solutions, answers. All of those words are synonyms to the words x-intercepts, okay? For that, if the discriminant is 0, right? So if I do the b squared minus 4ac and my answer is 0, one solution. So 0 means one solution. This number right here means two solutions or two x-intercepts. So if my answer is a positive number, it means that the graph crosses twice. Again, we're not really worried about what the graph looks like. We're just saying, hey, does it cross twice, maybe once? And from there, if the discriminant is a negative number, that means it doesn't cross, right? So I can give you a visual demonstration of each of these here. Negative, it does not cross. So let's say here are 3, and these are not the only ways that this can look. But look, if it just sets right, that's not very good. If it just sets right there on it, right, it just crosses once. Here, maybe it's upside down or right side up, really doesn't matter, but it crosses twice, you can see. And then other times you might say, oh, well, here's one, right? See how it is above and then never really gets down low enough to make that happen. So if we're going to find the discriminant of these 3 x-intercepts, this one will have, right? Now remember, A is always the number with the x squared. B is always the number with the x. And C is the number with no x's right there. So here we go. A equals 1, B equals 6, C equals 9. B squared minus 4ac. So 6 squared minus 4 times 1 times 9. All of that simplifies to 0. So that means it has one x-intercept right there. A, B, and C. A is 1, B is 0, C is negative 16. B squared minus 4ac. So 0 squared minus 4 times 1 times negative 16. That simplifies to positive 64. Make sure that you can use your calculator, right? That just means we have 2 x-intercepts. And the last one here, if A is 2, B is 4, and C is 7, B squared minus 4ac. And so that's a 4 squared minus 4 times 2 times 7. Again, we could just use our calculator, but it looks like it's just going to be 16 minus 56 or negative 40. That is no x-intercepts, right? The number is negative, so therefore I can't have any x-intercepts. Now, this last one brings up some interesting thoughts, and we're going to start connecting some of the stuff that we've been doing even more so. Think about this number right here. If it's negative, and let's just say hypothetically it would be under a radical, that means that there is no real solutions, right? We talked about this. This negative under a radical just meant the number I. And so if there's no real solution, the parabola never crosses the x-axis, which means that there's no actual x-intercepts. So this negative number, and we'll talk about this after fall break, really is underneath the square root. It says if there's no real solution, there could be a imaginary solution or an imaginary number. And that's something that we actually have already talked about. Okay, so real number solution, we could say that this is, if we're just using, again, the b squared minus 4ac, a is 2, b is 4, and c is 7. And remember, make sure that you're plugging in the right numbers. It's not always the first, second, and third. So it's 4 squared, 4 times 2 times 7. So we already did this one. This one was, what was this? Negative 40. So again, that means that there would be x-intercepts, but there would be 2 imaginary solutions. Okay, and this will help us out when we kind of do that. I want to bring up a couple things. Some things that we see on the PSAT is you might see something like this. You might say, hey, x squared plus bx plus 9 equals y. What number, and they'll ask the question like this, what number is b to have one x-intercept? So we know we have b squared minus 4ac, and because it says it's one x-intercept, I know that it has to equal 0. I don't know what b is yet. So b squared minus 4 times 1 times 9 equals 0. B squared minus 36 equals 0. Again, multiplying those together. I can move the 36 over, and it looks like b could be two numbers. B could be 6, or it could be negative 6, right? Both of those ideas actually do work out. Another applicable thing for this is actually using some story problems. And this is something that I do want to see. This next one, again, just like the previous problem, was not in your notes, but I want to take a look at this problem anyway. So flipping something, just a textbook open, so we could maybe even write something down here. Let's see, pretty close to it. I think there it is, yes. All right, let's say that an object follows this equation. H equals 80t minus 16t squared. Now, this equation is already given to us, right? And so what I want to do is, will the object, here's the question, will the object ever reach 90 feet? It's basically just a yes or a no, right? And so we could use this equation. This number deals with gravity right here. Like if we're going to shoot a rocket or throw something up in the sky, we know it's going to come down unless we use some force to keep it propped up. This 80 is the initial speed right here that we're giving an object, right? Again, those numbers really don't matter. They would be given to you anyway, but just for those of you that might be in physics or at least heading that way, this is kind of a good physics question here. It says, will the object ever reach 90 feet? So what we could do here, the 90 is a height. So I could go ahead and say 90 equals 80t minus 16t squared. And because everything's not on one side, I'm just going to move the 90 over. And be mindful that things look a little bit backwards here. What I mean by that is usually the squared term is first, but that's just not the case here, right? And so we have b squared minus 4ac. And so that just says 80 squared minus 4 times negative 16 times negative 90. Remember, the c is always the one without x's. The a is always the one with the most amount of x's, and b is the one in the middle. So we could just use a calculator here, right? So I'm going to pull open one. Let's see if we can just even do this. Just throwing over Desmos here. And so looks like here's my equation. So it just said 80 squared. So parentheses 80 squared minus 4 times, it was negative 16 and negative 90. Now here's what I'm looking for. See how the number that I get is 640. That's important to note because think about this. The number I got was positive. So if my number is positive or 0, then my answer is yes. It will reach 90 feet. If my answer was negative, then my answer would be no, right? So we could have even seen a different problem, and maybe instead of 90 feet, maybe it was 300 feet. And notice that my problem would have looked a lot different. B squared minus 4ac. B would still have been 80 squared minus 4 times negative 16. But this time it's times 300. And in fact, it would be negative 300 if we're switching things over. So let's just go ahead and throw that in there. See how my answer is negative now? It wouldn't get to 300 feet, but it would reach to 90. So these are some problems that we're going to see here just using that initial velocity. All right, students, I hope you have a great fall break.